So in section 3.6, we talk about PEMDAS and the order of operations. So now we'll have up to any combination of the order of operations. Something that's useful to have them do is to use a highlighter to highlight how many operations they are. They start to get bogged down when they see these, and they're tempted to just do whatever operation comes to them first or they find simplest. So if they start with there's an operation, exponent, and there's subtraction, then they could say there's 3 steps I need to do, and we try to get them to do all 3 steps separately, even when you can kind of crunch one into a single step. Like here where you could write 9 plus 12 plus 2, have them do the exponent first, then the multiplication. That way they'll begin to see patterns and they're less likely to make errors. Some things you already know. Okay, even though we went through multiplication and division and addition and subtraction, sometimes they now think they have to do multiplication first or addition first. Remind them that it's left to right. Okay. And the other thing that this tends to do is they think they do everything from left to right. So they now forget, for example, they'll do 2 times 4 first because that's the first operation on the left. So we do these from left to right, but we start with parentheses, exponents, etc. Now we're starting on properties. In 3.7 we have simple examples here in context that are meant to illustrate that addition is commutative, subtraction is not. Okay, so we don't spend a lot of time saying identify which property is being used, but we do want them to see why commutativity holds for addition, not subtraction. Here's an example with addition. Let's just look at the subtraction. Minnesota was 8 degrees, it dropped 5 degrees. And here we have Alaska was 5 degrees and it dropped 8 degrees. And I'm sure you've seen that a lot of students will say that this is 3 as opposed to -3. Okay, so for all of their time spent in whole numbers without integers, they were told subtraction is subtracting the smaller number from the larger number. So they look at this and they just find the magnitude or the difference of 3. Okay, we've done integers, so they should know that the second one is -3 and not +3, but we want to reinforce this idea and really use the context to show them starting at 8 and dropping 5 is a lot different than dropping 5 and or starting at 5 and then dropping to 8. So again, trying to use this context to let them see the difference. We also tell them that when you subtract in the reversed order, you get opposites. So that's a nice pattern for them to notice. Okay. Then applying the commutative property of addition. So we want them to see, we know that we can rewrite subtraction as addition. If we rewrite all the subtractions as additions of the opposite, then we can add in any order we want because everything is addition by the commutative property. If we change this to all adding problems, we can add in any order we want. So this problem is meant to show the usefulness of that. Granted, writing the expression as addition only is a little bit tedious, but once they see, well, I can add up all the positives, add all the negatives, and then just subtract once, that's a lot better, even though I don't think this ever becomes a negative number. But that's a lot better than saying, I'm taking the difference, is it positive or negative, repeatedly, because addition's generally easier. Okay. Then this is to illustrate commutative property of multiplication, and that division is not commutative. So focusing on the division not being commutative, showing them if 2 people share 4 pizzas, they each get 2 pizzas. If 4 people share 2 pizzas, they each get half a pizza. Granted, we haven't officially talked about fractions yet, but you can draw 2 pizzas, cut them into 4 pieces, and they all know what a half is, theoretically. Okay, so getting them to see that reversing that order, writing these symbolically as 4 divided by 2 and 2 divided by 4 to help them see that multiplication is commutative, division is not. Okay, so we haven't started on fractions yet, so we don't rewrite division as multiplication of a fraction to take advantage of commutativity like we did with addition, but they still need to know that. Okay. For the associative, we look at all of the operations and group in different ways and have them see if the results are the same. So have them do what's in parentheses first to illustrate that they are not. Okay, and that the bonus for this is, since addition and multiplication are associative, you can multiply or add in any order you want if it's all addition or multiplication, which can be useful. And the distributive property, so they've seen this a little bit when they did rectangle multiplication, but that was really repeated distributive property. And here we're just focusing on partitioning a rectangle into two pieces so they can find the area of the whole garden, and that's equal to the area of the tulips plus the area of the morning glories, which gives us this expression down here. Okay, so getting them to see where this distributive property is coming from. And of course they say, I just want to add 10 first. Why would I ever have to write it this way? And you know that we want them to get ready for algebra. When one of these numbers is an x, they can't add first because they don't know what x is. So we're trying to connect these ideas now with numbers rather than with variables. Okay. And there's problems like this in Math AS as well. We have them perform the parentheses first and then write it with the distributive property, so 5 times 3 plus 5 times 4. Note in Math AS, if it's subtraction, we keep it as subtraction. So here we don't immediately go to plus 7. We'd have -1 times 3 minus -1 times 7, and then we simplify afterwards just to be consistent with our distributing. And the last section, inverses, identities, ones and zeros. So this is pretty straightforward, traditional. We talk about additive identities and inverses and just have them look at a bunch of problems. The idea being when they're looking at all these problems, they're strategically clumped together so they can start to recognize patterns. Adding zero doesn't change the output. Adding a number and its opposite gets you back to 0. Okay. And I think there's another page. There it is. Then multiplicative identities, zero property of multiplication. So we don't really talk about multiplicative inverses because we haven't talked about fractions, but they can look at some, but they can look at some examples here, 5 divided by 5, -5 divided by -5. So division as an inverse operation when we get back to the identity of multiplication as opposed to multiplying by the reciprocal. Okay. Notice we also have dividing by 0. We're going to say that's undefined. I think in Math AS we write DNE for does not exist. And here's one justification for that. If you'd like one, there's lots of ways to justify why dividing by 0 is undefined. Okay, so these are the special cases that we look at that seem so simple, but for some reason they have a difficult time with them, so it's good to draw attention to them explicitly. And that's it for Unit 3. That's it for Unit 3. And the next videos will be on Unit 4.